All right, guys, before we get started, are there any questions on the homework? Questions on the homework assignment? We good? Okay. Yeah, we can get those here. Because, again, I wanted to go on and get this lesson in because we have this one and one more. 5.6 and 5.7 are the last two sections that we have for this chapter, and then we are finished learning new material, and we have our last test. Now, 5.6 is composite functions, composition functions. Now, there's two main ones that we have. One is I sometimes refer to as fog f of g of x. And for the most part, we're going to see it as f of g of x. And the other one is Goff. And this is g of f of x. F of g of x and g of f of x. Now, these aren't the only two. We could have f of x or g of x, either one, but we have these here. And for all of these here, we're going to work from the inside out. So we would start with the one in the middle, or one in the farthest inside, and then work our way out to get the function. And that seems a little weird, a little odd, but it'll make more sense once we actually start looking at it. Now, the first one we have is this here. So it tells us that f of x is x plus 2, g of x is x squared plus 3. And we're going to find f of g of a. Now, the first two, we're going to do f of g of a just so we can see what we're doing. Because, unfortunately, x, especially the first few times, doesn't make a whole lot of sense. Well, I'm going to retract that statement. Because our first step is not going to seem like we're doing much with g of x. So I want to do g of a first for this one here, f of a for the next one, so that we can see kind of what's going on. Because the first thing we're going to do is go from the inside out. So we're looking at g of a. Well, they tell us g of x is x squared plus 3. So we're going to plug a into g of x. So we're replacing every x in g of x with a, which would be, so we'll still have f. So we replace this x here with a, which means every x in the function is being replaced with a, giving us a squared plus 3. Or we can say f of a squared plus 3. We don't necessarily need the parentheses. Questions on this so far? Are you good with all this here so far? Yes? So the first thing we did was plug a into g of x and got a squared plus 3. Now we need to take f of a squared plus 3. So at this point here, well, we have f of x. F of x is x plus 2. But we don't have f of x anymore. We have f of a squared plus 3. So we replaced x in f of x with a squared plus 3. So every x in its function is also going to be replaced with a squared plus 3. So instead of x, we have a squared plus 3. And we still have the rest of the function plus 2. So we're just replacing the x with a squared plus 3. And then we have our plus 2. Questions on this here so far? You good with this here so far? Yeah. Well, we can drop the parentheses and simplify. So we have a squared plus 3 plus 2. Well, our 3 plus 2 gives us 5. So f of g of a is a squared plus 5. Questions on this here? Questions on anything we've done so far? We good with this here? Yes? All right. Now the next one we're going to look at is g of f of a. Now again, I'm switching it to a so we can see the different steps that we're doing, especially the first one, plugging it in. because we are plugging in something even with f of x. We're plugging x into f of x. Oh, it doesn't seem like we're doing much. So again, we're going to work from the inside out. So the first thing we're looking at is f of a. So our f of x is x plus 2. Well, we replace the x with a. So everywhere in the function x plus 2, we're going to replace x with a. Okay. Well, we don't necessarily need the parentheses, so it's just going to be a plus 2. Questions on this so far? We good with this here? Oh. G of x is still x squared plus 3. But we don't have g of x anymore. We have g of a plus 2. So we're going to replace every x in our function g of x with a plus 2. So instead of x squared, we have a plus 2 squared. And we still have our plus 3. So essentially everything's the same. We're just replacing every x with a plus 2. Questions on this here? Are we good with this here so far? Now we do need to simplify the a plus 2 squared. Well, a plus 2 squared is just a plus 2 times a plus 2. We're just going to multiply it out. And a plus 2 times a plus 2, well, we can distribute. Our a times a is going to be a squared. A times 2 is plus 2a. 2 times a is plus 2a. And lastly, 2 times 2 is plus 4. And we still have our plus 3. And last but not least, we're going to combine like terms. A squared doesn't have any like terms, so it's just a squared. 2a plus 2a is 4a. And lastly, 4 plus 3 is 7. So f of g of, not f of g of f of a is our a squared plus 4a plus 7. And that's it. So we're working from the inside out. We plug whatever's furthest into our first function, simplify that, and then take that and plug it into the next function and go from there. Questions on this here? We good with this here so far? Okay. That fly is quite massive. So if we feel kind of comfortable with how this works, we're now going to switch over to it just remaining as x. So our next one is f of g of x. So we're going to start from the inside out. We're going to start with our g of x. So we're going to plug x into g of x. And well, if we plug x into g of x, well, our g of x function is 2x minus 4, so we're replacing every x in the function g of x with x gives us 2x minus 4. So it really doesn't change anything. So that's why I like using the first 1 or 2 with a so that we can see how we're actually plugging something in. Here we are, but it doesn't change how it looks. Questions on this so far? Now we need to take f of 2x minus 4. So every x in f of x's function, the cubed root of x plus 1. So this x here we're going to replace with 2x minus 4. So when we plug it in, we'd have the cubed root And instead of x, we have our 2x minus 4 plus 1. So this is the exact same process, but instead of having a, we just have our x. And now we need to simplify. So we can drop the parentheses, 2x minus 4 plus 1. And finally combine like terms. And it'd be 2x minus 3. Questions on these here? Like these here so far? I mean, probably using like loosely for y'all. G of f of x. So again, we start from the inside out, so we'll start with f of x. So we're plugging x into f of x, or really we're just replacing f of x with its function, which is the cubed root of x plus 1. So we replace it first. Now we're going to take g of the cubed root of x plus 1. So we're going to take every x in g of x and replace it with the cubed root of x plus 1, which will really give us 2 times the cubed root of x plus 1 minus 4. Now if x showed up more than once, we would have to plug it in every single time. Questions on this so far? Now we just need to simplify. And the only thing we really need to simplify here is our 2 times our cubed root of x plus 1, which is just 2 cube roots of x plus 1. We're just multiplying it. Now we can't multiply it into our cubed root because the 2 is not inside a cubed root. Now if it was the cubed root of 2 times our cubed root of x plus 1, then yes, we can multiply the 2 and x plus 1. But since the 2 is outside the cubed root, it stays on the outside.
Mikhail, let you come to the office. Mikhail, let you come to the office.
But that's it. Questions on this here? Are you ready for the next one? F of g of x. So again, we start from the inside out, so we'll start with g of x. Well, g of x is 3x plus 5. So we're taking f of 3x plus 5. So we replace x or plug x into g of x. We're just replacing g of x with its function, 3x plus 5. Now f of 3x plus 5, we're going to replace every x in f of x with 3x plus 5. So our 2x plus 7, yes, we will be using it. So we'll still have the 2, but instead of x, we'll have 3x plus 5 plus 7. Now we'll distribute the 2. 2 times 3x is 6x. 2 times 5 is plus 10 plus 7. And our 10 plus 7 is, so our f of g of x is 6x plus 17. Questions on this here? We'll do one more of these. Instead of g of f of x, let's take g of x, g of x. Now the process that we do for g of x is no different than g of f of x. But the first thing we're going to take is our g of x. And plug x into g of x or replace it with its function, which would give us 3x plus 5. Now, essentially, we're going to do it again, kind of. But this time, instead of taking g of x, we're taking g of 3x plus 5. So every x in g of x, we're going to replace with 3x plus 5, giving us 3 times 3x plus 5 plus 5. The last thing we need to do is simplify, so we would distribute our 3. 3 times 3x is 9x. 3 times 5 is plus 5, giving us 9x plus 20. G of x. So g of x, f of x, not any real different, but instead of using two different functions, we're just repeating the same for one function twice. Questions on this here? We good with these here? Yes. Now we're going to evaluate composite functions. And the first one we're looking at is f of g of 3. And again, even though we have a number instead of a variable, it's still going to work out similarly. So the first thing we're looking at is g of 3. Now, even though we don't have a variable, we're still plugging that 3 into our g of x. So we're replacing every x in g of x with 3. So instead of x squared, we have plus 2. So we just replaced every x in g of x with 3, giving us 3 squared plus 2. Now there's different options we can go from here, because we can take the 3 squared plus 2 and plug it into f of x. It's possible, it works, I would not completely advise it. And that's because, can we actually evaluate 3 squared plus 2? Does it have a value? Yeah. So there's no reason for us to either A, type this whole thing into the calculator, or do it by hand, because 3 squared is 9, and 9 plus 2 is 11. Because it's going to be a little bit easier to plug in 11 into f of x than it is to plug in 3 squared plus 2. Because if we plug 11 into f of x, we replace every x in f of x with 11. We get 3 times 11 minus 4. And again, at this point here, you could type this whole thing into the calculator, let it do it for you. Or if we did this by hand, 3 times 11 is 33. And 33 minus 4 is 29. So f of g of 3 is 29. That's it. Questions on f of g of 3 before we look at g of f of negative 1? Now the first thing we're going to look at is f of negative 1. So we're going to plug negative 1 into our f of x. And if we do that, we get 3 times minus 4. Now at this point here, again, we can do this by hand or in the calculator, either one. As 3 times negative 1 minus 4 is negative 7. Yep, because our 3 times a negative 1 would be negative 3. And negative 3 minus 4 is indeed negative 7. So we get g of negative 7. And again, at this point, now we're going to take g of negative 7. So we'll plug negative 7 into every x in g of x, which would be negative 7 squared plus 2. Again, we can grab the calculator and say negative 7 squared plus 2 is 51. Now, it is important to put the parentheses around the negative 7 squared in the calculator, because if you don't, well, get negative 47. Because it'll square the 7, which is 49, and then it'll attach the negative to it, multiply it by the negative 1, and then add 2. Questions on these here? How do we feel about these composite functions, especially evaluating the value? We feel good with these here? Yes. All right. Well, I want to skip these two and go on to this one here. So I'm going to do one that's a little bit different, just to show you that no matter how many times we have it or what it shows up as, it's not that bad. We work from the inside out. Yeah, I would write this one down. This one. So we're going to take f of g of f of g of g of f of 0. F, G, F, G, G. And again, we're going to start from the inside. So the first one we're going to look at is f of 0. F of 0 would be 4 times 0 plus 7. Now, the number of parentheses after it is not as hugely important, because if you forget one or add one too many, it's not that big a deal. Because the first thing we're looking at is f of 0. Well, f of 0 would be 4 times 0 plus 7. G, F, G, G. Now, 4 times 0 is 0, and 0 plus 7 is 7. Yeah. Questions on this so far? We good with that there? Well, now we would take g of 7. F of g, F of g. Now, since we're taking g of 7, we're plugging 7 into g of x. So it'd be 3 times 7 plus 5. F of g of f of g. Now, again, at this point, especially with these bigger ones, I'd start utilizing the calculator, letting it do a lot of these calculations for us. Now, 3 times 7 is 21, plus 5 is 26. Well, now we're taking g of 26. So our g of x is 3x plus 5, so we'd say 3 times 26 plus 5. At this point here, I'd type that whole thing in the calculator. Three times 26 plus 5 is 83. So what do we think of this so far? I don't think as much difficult as it is tedious. So we're looking at f of 83. So f of x, 4x plus 7. So we're saying f of g of 4 times 83 plus 7. And again, we can type this in a calculator. Times 83 plus 7 is 339. Oh, that's right, because we had to do G. Twice. I thought it had been a minute since we did that. Now we're taking G of 339. Well, it's going to be 3 times 339 plus 5. And if we type that in, we get 1022. And lastly, we have 4 times 1022 plus 7, and then we're done. Which is 4095. It's not that this is so much harder than what we've been doing, it's just very tedious. Yes? Questions on any of this here? We feel good with these here, evaluating? Hope so. But we have one last thing we're going to cover, and that's these here. And it's not that they're any different, they're just a little weird since we actually have negatives. I'm not going to worry so much about the domain. We can save that for college algebra. So, f of g of x. Well, our first thing is to plug x into g of x, or just replace it, giving us f of 2x minus 4. Now, just like we've been doing, we're going to plug 2x minus 4 into every x in f of x. Which would give us 2x minus 4 to the negative 1, yes? And I do find this interesting because up to this point, especially with this chapter, we cannot leave variables with a negative exponent. We can't leave an exponent negative. But the book says that's fine. I find it odd that it just suddenly is like, okay, we're going to leave it there. But we do have this here. Now, if you do want to simplify it down the way we've been doing it, it's just going to be 1 over 2x minus 4. We move the whole thing from the top of the fraction to the bottom. Now, if there had been a number in front of it, like say it was 3x to the negative 1, we would have the 3 in front of it. Now, the 3 would not multiply through. As much as we would like it to, that it would be 3 times our 2x, 3 times our negative 4. That's because the 2x minus 4 is actually in the bottom of the fraction, yes? And when we multiply a fraction, this number in front is not multiplied by the bottom, but by the top, which would be our 3 times 1, which would be 3 over our 2x minus 4. Does that make sense? So that's part of the reason the book, especially with this here, the 3 out front would leave it there. But since we don't have that 3, I will take 2x minus 4 to the negative 1, or 1 over 2x minus 4. Okay? I will have to count off points if you put 2x over negative 4. I'll just have that split up for some reason. But questions on this here. G of f of x. All right. Well, the first thing we'll do is plug x into f of x, or replace f of x with its function, which is x to the negative 1. Now, we're going to take g of x to the negative 1, so every x in g of x is going to be replaced by x to the negative 1. Pretty good with this so far. Now, this here and the previous one with our negative 1 are a little bit different. because it's not applied to the whole set of parentheses, we can actually multiply these two. 2 times x to the negative 1 is, well, 2 times x to the negative 1 minus 4. And this here we could say is our final answer. Because if we did get that exponent positive, it'd be 2 over x minus 4, which for some odd reason looks a little bit weirder than 2x to the negative 1 minus 4. But these are the same thing. Questions on any of these here? We feel good with these here? Yes? All right. That's it.